Welcome to the Chicago Java Users Group for November, also known as CJUG. Tonight we're going to learn Java features and Eclipse Collections APIs using code Katas with Donald Raab and Sirisha Pratha. Our featured panel speakers tonight, we have Donald Raab, Managing Director at BNY Mellon, creator of the Eclipse Collections Java library, a Java champion, and a blogger and presenter. And we have Sirisha, who is a senior specialist developer at BNY Mellon, is a committer of the Eclipse Collections Java library, is a Pittsburgh Jug leader, and is a blogger. So without further ado, let's welcome our panelists and we'll get the show going.
Awesome. Thank you, Josh. Thank you.
Thank you, Josh.
Thank you, Josh. So I was going to introduce myself, but Josh did a great job. So thank you, Josh. I will get started with our presentation today. So today we'll be talking about, learning about new Java features and also some advanced Eclipse Collections API. And before we get on and start with the hands-on programming session, I will introduce a couple of topics. So the first one is, so this is where you'll find our BNY Mellon code katas. We are on GitHub repo. So you can, Don, if you don't mind, can you share the link on the chat window?
There we go.
Perfect. So this is for everyone to go in and check it out and explore this on your own as well. But I want to definitely show a couple of things that we've done already, which will introduce the Java features that we have been adding and also the Eclipse Collections API. So what is Kata? What is a Kata? So katas are basically small exercises that practitioners of an art form.
Can we mute everyone?
Yeah, I thought it was just me. Cool. I'll resume. Cool. So I guess what is the kata? Katas are basically small exercises where practitioners of any art form can repeat them over and over again to improve their skills. If you extend that to programming, you have code katas. So they're basically hands-on programming exercises which you can use to improve your skills. So the way the code kata is set up here, at least in this version, is that there are a series of unit tests which will fail initially, and our goal is to make them pass. And along the way, we will end up learning a new API or a new feature or whatever is the goal of that exercise. So we have a couple of katas right here. As you can see, we have some good description as well. So you have the Lambda kata, deck of cards kata. You have a kata for learning about the Eclipse Collections data structures and algorithms. You have donut kata and a couple of others. Today, we'll be focusing on the donut kata and the deck of cards kata. In order for you to actually do this on your own, you'll need Java 15. And then you'll need the enable preview features, which typically happens, which you can typically change or change in your IDE. You'll need Maven 3.6.1 and above, and any IDE of your choice. We are going to be using IntelliJ IDEA in this session, so but it should work fine in any other IDE as well. With that, I'm going to jump straight into Donut Kata, and we can take a look at it. So Donut Kata, as you may have guessed, is the theme behind it is a donut shop. I'm going to zoom in a bit. So what we have here, we'll just quickly go over the domain classes right here. So when we actually do the hands-on programming session, it'll be much easier to understand. So we have a donut, we have a customer, we also have an order, and finally the delivery. And then what we also have is the donut shop. The donut shop can make donuts, it can deliver orders, and then we're going to be implementing a couple of these methods right here in order to learn new APIs within Eclipse Collections. Now, each donut also has a donut type. I recommend not looking at them because it'll make you hungry. It does that to me all the time, so don't look at it. But that's with that, I want to introduce the two new features, at least relatively new. One of them is the first one is the local variable type inference. This was introduced in Java 10. We've linked both these JEPs right here, so you can definitely take a look at it when you're here in this GitHub repo. But local variable type inference was introduced in Java 10. Java 10 seems like it was so long ago, given we just had Java 15 release in September, 2 months ago around this time. And but it still, I think, is relevant to talk about this feature because the most popular, at least it seems to me, that the most popular production Java version is still 8. And as folks migrate to Java 11, you can use local variable type inference. Now, what is type inference? Type inference is just a mechanism for the compiler to infer the variable type. Now, Java is still a statically typed programming language. So what that means is the compiler can infer the variable type at compile time and not at runtime. And that inference happens through initialization. And we'll see a couple of examples real quick in just a second. And also, and I guess the main goal behind local variable type inference is introducing this feature is that it improves code readability and it also reduces boilerplate code, which we will see why that is the case. So I'm jumping really quick into my IDE. We will go over the structure in just a second, but just to give you a couple of examples of how we are using it. So the way to achieve type inference in Java the way it is right now is by using the reserve type name var. So this is how typically we would have written. So I'm going to just reduce this for a second. The way we would have done this before Java 10 is delivery object, and then you have a method. So this is the initialization right here. But we would also let the compiler know what the type is on the left-hand side. But with the introduction of var, what you can simply do is this. Now, there are certain do's and don'ts of how this can be done. So because this is limited only to local variables, you can only do this in methods. You can do these in for loops, in try with resource statements, but there are certain places that you cannot do. So for example, you cannot do it in these class fields right here because the compiler can't tell what this is. So this is a bad example. This is like a don't, like do not do this with var. Well, of course, your compiler,
It's not going to let you do it anyways.
Exactly. And then if we do deliver order, let's see. So these are some of the other places where you can't use it. So you can't do this. You can't use it in your method parameters. Again, the same reason. It's hard to tell at this point what this variable is. And you can't use it in return type even because let's say the method implementation itself changed at a later point. This can introduce either like source or like even binary incompatibility. So that's the reason why none of these will work. But as you can see here, right here within the method itself, we can use var. So var customer, because the compiler knows what it is from the right hand side, it can infer the variable type and make it easy for us to not have to write all of that out on the left hand side as well. So this is a great new feature which you can do, which you can see this pattern across all of this Kata. I think someone asked if we can do this in for loops. Yes, for loops is a great example because there is a subtle, there is that initialization that happens, right? So it can infer the variable type using that. So that is type inference. Coincidentally enough, this next pattern, this next feature that we are talking about was also introduced to improve code readability and reducing the boilerplate code, which is called records. Records was introduced in JDK 14 as a preview feature, and it was also released in JDK 15 as a second preview feature, and it is now officially confirmed to be part of JDK 16 release in 2021. This turned out to be a crowd pleaser for everyone. So the Java community definitely, I think, is very, very happy about this records feature. So I just want to quickly share how this works. I think it can be best explained using a code example. So I'll just show you what we can do here. So if you take a look at this donut class right here, it has type and price. And if we were to write a class for this, what we would have done typically is this way. So we would have had a class, we would have given the class fields, a default constructor, and then the getters, equals, hash code, toString method. Now with the introduction of records, which is a type of class, and what we can do simply is, and this is, if you're seeing this for the first time, then this is indeed magical. So all of that code is actually now just reduced to this one line. And so with just this word, and then you can basically have the class fields within the parentheses, and then you have the open and close bracket right here. Now, there is a reason why there is this empty brackets right now, because there is flexibility into what you can actually do within these brackets, within these parentheses. And we'll see a couple of examples right here. But I want to quickly jump in and show you. Oh God, I can't actually. Okay, that's good. That's better. Okay, cool. I wrote this blog a couple of months back, but it's now available on fuje.io. So what happens behind the scenes? Like, how did we get away by not writing all these getters and, equals, hash code, and toString methods? Like, how did we end up with that? So what really happens is, behind the scenes, the compiler is actually generating all of this code for us. So when you've built the code, this is what you'll see. This is from my target folder. I just took a screenshot of it so people can quickly see, what is happening behind the scenes. The first thing to note here is it is creating a final class, donut, and it extends javalang.record. It has the type and price information as final fields. It has the default constructor, which generated it for us. It also generated toString hash code and equals method straight out of the box, and the two getters. Now, they look a little different from how we would write it, because it doesn't have the prefix get in it, but it behaves exactly like the getters we would normally write. So this is nothing but get type and get price, but they have removed the word get. So there is no prefix get, basically. So this constructor that you see right here is called the default constructor, also known as the canonical constructor. And there is some flexibility to writing some custom constructors and some others. We'll look at those examples right now. So what you have here is a compact constructor. So it is the same. It's the same as the canonical constructor, in the sense that it takes the entire argument list as it did with the default constructor, but you don't have to explicitly mention it, hence making it like a compact version of it. Also, what you're not seeing here is the initialization for order and donuts. So you're not seeing that information, but it's happening behind the scenes. And then you can add additional business logic. That is your compact constructor. So look, I also gave, what do you call this? The generated compiler code. So you can see that both order and donuts made it into this. So the last type of constructor is the custom constructor. So this is a bit different from the other two, because you can actually override the arguments, so the method parameters itself. So instead of just having customer date and counts, which would make it the default constructor, you can actually have a different type of an argument. But the only thing that you would have to do here is delegate it to the default constructor and then write whatever business logic you would write. So the one other thing too, I think that's worth mentioning here is there is no argument constructor here, and I made a mention of that right here in my blog as well. It's because all the fields in record are final, so that means they have to be initialized as part of the default constructor logic or in one of the constructors right here. So there are, of course, like there are.
Quick question: does that imply these are always thread safe?
Sorry, I can't hear you really well.
Oh, does it imply they're always thread safe?
I would say the answer to that is no. And the reason being is that even though the records themselves are, going to be, let's say, effectively immutable, they can hold on to mutable data structures. So for instance, like you could hold on to a list, right? and that could still be mutated. So there's no guarantee that all the state inside of a record that you create is actually immutable. But if you created a record that was immutable and it couldn't change state, then yeah, it would be thread safe. So I would say, it's conditional upon how you implement it, right? And so in the case of, I think, is it delivery? Can you scroll up?
Yeah. Yeah.
I think you had one that had an immutable list, right?
That was, yeah.
That one. Okay.
Yeah.
So delivery would be thread safe because you couldn't change anything here, right? Order itself is immutable. It's taking an immutable list. There's nothing that can change here, right? So it's thread safe. But the other one you have below, I think, had a mutable data structure on it, right? Scroll down.
Yeah.
Yeah, so you see, yeah, that's immutable.
Right.
Am I imagining I saw one with mutable?
Maybe it was in a different class that we were looking at earlier, but yeah, right here, mutable bag.
Okay, thread safe, right? Because someone could mutate the bag, and it would change. So there's no guarantee that the state is the same. So.
Thanks.
You're welcome.
So I want to quickly just go over the advantages and some of the restrictions of using records. So definitely with just a few lines of code, you can actually clearly see that the donut is representing type and price information. It is a data container. It's best suited, I think, for for data modeling and for schema design. There has been some talk about, it actually replacing Lombok. It isn't there yet, but it's just one of the different ways in which you can actually reduce boilerplate code. That is what it is. So there are certain restrictions of using records because records are implicitly final, and the reason is intention. I mean, the restriction is intentional because we want the record to be not modified by another class or a record, and we want to preserve the state, as in the fact that it is type and price information. So you cannot declare it as an abstract class, so it cannot be modified later. You can't extend from other classes because it's already extending java-lang.record, which we saw earlier, and you can't declare instance fields as well because the only fields that you have access to are the ones that we mentioned in the record descriptors itself. So in this session, we are not going to go over the setup and how do we set this up in IntelliJ and things like that. But if we have time at the end of the session, we'll definitely do that. So that is record, and you will see this when you actually check out this project. You'll see that we have all the examples right here. Those were just screenshots of just examples from here. And when you're using them, you can see that we have added additional logic. We've added custom logic either to the constructors itself or even written additional methods. So I'm going to shift gears here a bit and talk about Eclipse Collections, because that is where we're going to learn about some new APIs within Eclipse Collections as well. Now, Eclipse Collections is an open source Java collections library. It has some of the popular data structures that you're probably familiar with, which is like list, set, map. And over and above that, we also have bag, multi-map, bi-map, etc. We have both mutable and immutable collections for these, and complementary primitive collections for all these primitive types. Eclipse Collections is open for contributions, and we will, we can take questions later about how you can go about doing that. But there are contribution guidelines on this project. Also, as you can see right here, we have several language translations which were contributed to us by the community, which we are very, very happy about and thankful. So with that said, again, there are several katas that you can explore right here if you wanted to learn Eclipse Collections, but the one that we are going to look at is the donut kata. So with that, I'm going to jump into the code kata itself. So I just want to quickly spend some time talking about how this is structured. So you have the donut kata and the donut kata solutions. The solutions can act as a reference for you as you're solving the donut kata. We don't have solutions for everything, but we'll surely add them in in how much ever time. We have donut Kata, and then we have both Java and Kotlin version, but for this session, we'll only do the Java version. So you have this donut shop test, and all of the domain classes that we just went over would be available here. So initially, we are expected to have all the tests fail for us, which is how it always starts with code katas. So all the tests will fail at the beginning, and we're going to solve each and every each exercise, and we're going to see all the tests pass. There are about 5 tests in this, so it should be pretty quick. So the first thing is the setup. So we have the donut shop. So obviously we have the make donuts. This is just part of the setup. There's nothing that we have to do here, but it'll be just helpful methods for us to get started with the exercises itself. So you have make donuts, you have customers, you have deliveries, and obviously these are all part of the order. So all of that combined makes up the setup. After the setup, okay, so this is the first test that is failing. So we're going to look at this and see how we can make this test pass. So the first task is to get the top 2 donuts, and is to get top 2 donuts, and the expectation is that it's going to be Boston cream and glazed. So if you looked at donut shop, we're going to go ahead and implement this method. So get top 2 donuts, and each of these tests have helpful hints of what APIs that we can use to solve this exercise. So what I'm going to do here is just follow along the hints and type out the code. So it says, look at the domain and use deliveries, which have a collection of ordered donuts. So I'm going to start with deliveries, and deliveries themselves have ordered donuts. You will need to flatten the donuts and collect their donut types. Now, flat collect is an API in Eclipse Collection. So what flat collect and even collect do are, they're both transformation patterns where you take a collection, you apply a function, and then transform it into a different type of collection. With flat collect, what you also get is that it actually flattens the data structure. So you have, in this case, you have a list of deliveries. Each delivery has a list of donuts. But if you wanted just all donuts as a linear, in a linear fashion, then you do flat collect. So what I'm going to do here is, for each delivery, I want to get all the donuts. So at this point, I would get a collection of donuts. Now, also, the next thing I have to do is collect their donut types. So that's what I'm going to do. I'm going to collect. These are, again, APIs that are unique to Eclipse Collections. So definitely when you're checking out this in the code repo and readmes itself for Eclipse Collections, it'll help you understand better. So you're collecting the donut types, and then I'm going to convert this into a bag, which is where we have the top occurrences API. So now bag is a data structure. Think of it as your shopping cart, right? So you have elements and the number of occurrences, so which is what is a bag. I have the bag, and then I'm going to do top occurrences n. So this should do the trick for me. I'm going to delete this. Oh no. Okay. So if I rerun the test at this point, it should, at least one of them should pass right now, which is get top 2 donuts. And I'm going to add a quick refactoring, just a method that will help us improve this code even more. So there is an advanced Eclipse Collections API called count by, which basically does that. So it actually collects the donut type and converts it into a bag. So which we can basically simplify this even more and use the count by operation. So you're counting and then also converting it into a bag. So you can actually use this API. So if I run this test again, it should still pass. So that's good news. So the next test that we're going to look at is the total delivery value by date. So for each of these days, we are looking for the total delivery value. Sounds simple. So let's look at this. Let's look at these. I'm going to condense this. Okay. Write the code necessary to sum up the total delivery value for the specified date. Again, I'm going to start with deliveries. And the first thing I want to do is solve for the select part, for the specified date. So there's an API in Eclipse Collections called Select, which takes a predicate and it evaluates all elements that return true for that predicate. So, for example, in this case, I'm going to say delivery dot delivered on the state. So this is simply it. All that it does is filters out anything that we don't need and filters in any deliveries that satisfy this delivery date. And I'm going to do sum of double, which takes in a function since I need the total delivery value. So it is still delivery and I'm going to get the total price. Return, control Y. Okay. So if I rerun the test at this point, I should have total delivery value by date go to success. Cool. So also, since we've been looking at method references, one other refactoring that I can do here is instead of doing it this way, I can basically say delivery. For each delivery, get the delivered on, and I can actually pass in an argument, which is date. So this basically does the same thing, except for in the method reference, and I can pass in an argument, which is date in this case. And it basically increases the reusability value of using this API. So I'm going to quickly run the test to make sure that I didn't break it. That looks good. So the next test that we have is get top customer. We are expecting Donnie Dapper to be the top customer. So I'm going to go ahead and implement this method. So it says write the code necessary to find the maximum customer by using the total donor as a function. So there is a method called maxBy. So I'm going to simply say this dot customers dot maxBy, which takes in a function. And in this case, I'm going to say for each, for the customer, if get total donuts ordered. So this is a good API for that. And if I rerun this test, I should see get top customer go to success as well. MaxBy is basically returns the maximum element after applying the function. Yeah. So the next test that we have here is get customers by donut types ordered. And here we're exploring a new data structure, which is multi-map. Now, multi-map is similar to a map. It has key and values. But if the values themselves were a collection, then what you have there is a multi-map, and you have several rich APIs on that as well. So the first thing I'm going to do is go ahead and implement this method and look at this hint. So it says group all customers by the donut types they order. So what I'm expecting to see in this multi-map is that for Boston Cream, there are like few customers who've ordered it, and for something else, glazed, there are a few other customers. So I'm expecting to look at that data structure right here. So I'm going to start with this dot customers. The hint says use group by each, which takes in a function. So I'm going to do group by each. And I want to see what options I have right here. So if I use customer, I want to look at get donut types ordered. So this should basically do the trick for me. And if I rerun the test, I should see this pass. Cool.
I guess just a quick comment on it. I guess, Sirisha, the difference between group by, and I'll be covering group by when I do the deck of cards kata. Group by each, basically, the result will be that every customer has multiple donuts types ordered, right? So there's multiple keys, right? So a customer will show up multiple times, which is different than group by, which suggests you're going to have a single key, right, for each thing that you're grouping.
Yep. So I'm going to go back and continue with this is going to be my last test. So let's look at that. So what we have here is donut price statistics. Now, what this does is we want to know what are the price statistics between these two time frames. And in this stats, at least it's called stats 1 here, what you can do is you can get sum, get average, and get count. And this is, again, another API within Eclipse Collections. So I'm going to follow along these hints, and we are going to solve this. So the first place is, the first thing is to select. So we have a time range here. So I'm going to start with deliveries. And we've already looked at this API earlier, select API, which basically takes in a predicate and any element that evaluates true for that predicate will get selected. So we have for each delivery, I'm going to say delivered on either the from date, or I'm also going to select any delivery where the get date is after the from date, right? After. And I'm going to do the same with the to date. So anything that is between these two time ranges, right? So I have the to date, but instead of after, I'm going to do is before this to date. So at least that will help me narrow down that time range. So I did this part. And now we also looked at flat collect earlier. So flat collect basically flattens this collection, which is deliveries, list of deliveries with a list of donuts. And I'm only interested in the donuts. So for each delivery, I'm going to get the donuts. And for each donut, I am going to only, because we are looking at the price statistic, I'm going to say for each donut, I need the price for it. Again, if you've noticed, I'm not using get price because this is all part of a record. So everything is now donuts price. There's no get in here at this point. So I'm going to do return and remove this line right here. And if I rerun the test, it should all pass. Cool. That was it from my end. With that, I want to hand it off to Don.
Well, actually, before we hand it off, I want to make one comment, which was I wrote this kata originally, and Sirisha converted, all of the domain classes to record, which is kind of neat to see. But one thing, I had never solved this particular unit test in this way. And I always struggle when writing it. I write out like a really horrible looking lambda. So it's kind of neat to see it this way. But what's interesting is Eclipse Collections has both eager and lazy APIs. And right now, Sirisha's been using the eager APIs. You can actually put, if you want to try this, Sirisha, put like .as lazy after this .deliveries. Nothing else should have to change.
I'm going
and run the tests again.
Yeah.
That's kind of the equivalent if you were, using streams, right? And that's one of the differences between Eclipse Collections and streams as well. Eclipse Collections has the methods directly on the collections classes, and when they're on the collections classes, the default behavior is eager. So select would create a temporary collection, select again would, but when you convert to lazy there, you're actually doing everything lazily, similar to like you would with streams. One additional difference is that the call to as lazy returns lazy iterable, and lazy iterable can actually be executed upon multiple times, right? Pretty much no limit. So it's somewhat similar to like an iterable where you can keep getting iterator for it, which is different than stream, where once you operate upon a stream, you can't use it again, right? It becomes exhausted. So but thank you. That was great.
Thank you. Yep.
And I will
I'll stop
share
sharing.
my screen now.
Yeah.
Okay. And I'm not going to, and we'll see at the end, I'm going to try and go through this fairly quickly, but I'll be covering the deck of cards kata. And if you look at the deck of cards kata, and we click through, what you'll see is the kata originally started out as a talk that myself, Nikhil Manavadakar, and Leo Lima, two other Java champions, gave at Devoxx US back in 2017. And we gave this talk, and we gave the talk a few times at different conferences. We gave it at Java 1, Devoxx US. I think it was given at GIDS. And I think at least 5 or 6 times we gave the talk. It was quite popular. And it's called Collections Compare. And its purpose was to basically compare different collections frameworks. So we were comparing basically Java collections and streams with Apache Commons collections, with Google Guava, with Eclipse Collections, with a framework called Vavr. And most recently, and this is something I'm going to be covering today, we've added a custom collections framework to basically see what it's like to leverage some of the new features available now, specifically in this case in Java 15. So features that have been coming out through Project Amber. We're actually using the sealed types feature, and what you'll get to see tonight is what that looks like in practice, and gives you an example of sealed types beyond just the common use case that's described, which is basically like if you have shapes and you want to limit the shapes to circle, square, and triangle, right? I think if you've looked at any sealed type literature at this stage, it's covering those kind of things. But deck of cards is somewhat similar to, let's switch over to my ID. And I'm not using Darkula, so hopefully the the brightness is not causing any eye pain now. Similar to the donut kata, we'll have a domain, right? And then the domain, looking back at the README, you'll see we have a card type, and card has rank and suit. Guess what? Card looks very much like a candidate for using record. So rank is just an enum, suit is an enum, and card is comparable. So there's an ordering that can be applied. And then we've got some, logic that we've implemented on card that we'll be using. But it's a simple domain. Most people are familiar with like a deck of cards, right? And that's effectively what we do is we want to build a deck of cards and execute different operations. What you'll see is that we have the domain. There's the card, rank and suit, right? Just click that. And then you have different packages basically for each of the collections frameworks. And corresponding supporting tests for them. So you'll see like we have an immutable list version of the Kata. There's also an immutable sorted set version, which has a set of tests and a set of deck of cards implemented for all of the different collection types. So the intent here is that if you really want to look at and compare collections frameworks, go in and compare the APIs. You can additionally, if you want, you could, and this is something that we did in the original talk, we did performance benchmarks, actually comparing the performance and memory that we're taking, because that was something that folks found very interesting. Because when you look at this like plethora of collections frameworks that are out in the universe, it's like, why would I choose one over the other, right? So we're trying to help, answer those kind of questions, right? But the thing we're only going to be concerned with today is actually looking at the APIs. And what I'm going to do is actually show you just the Eclipse Collections implementation today. And I'm going to compare it against the custom collections framework that we've built. And in the custom collections framework, you'll see, and this is all part of the Kata code base, you'll see that we've implemented more or less the basic infrastructure for a full collections framework, leveraging features, once again, anything that we can grab a hold of up to Java 15 preview features we're using, right? And you'll see different places where we're using, sealed types, and specifically, there's a separate blog, and I'll send you this link. How can I go to the chat? Let's see, there we go. So we have a set of immutable collections that we've implemented, and basically there's a parent interface called Iterable. There are immutable collection interfaces, and what you'll see is each of the immutable collections interfaces are sealed, right? And we'll step through the code. And the goal that we were trying to achieve, and the Kata works very nicely for this, because basically in the Kata, what we need to do is, in order to create our deck of cards and to get things in passing, we want an immutable list, basically a sorted list that's immutable, as our deck of cards, right? And the interesting problem that we were able to, basically come up with a solution for using sealed types is when you create an immutable list type, right? And there's different strategies for doing that. There's three aspects of immutability, and I described them in this blog. One aspect is contractual immutability, where an immutable interface shouldn't have any methods that look like they can mutate the data structure. So you shouldn't have methods like add all, remove all on them, right? And then it means that the API is safe to use. You're not going to call an API and boom, the thing barfs on you and throws an unsupported operation exception when you call add or add all, right? Then obviously the most important part of an immutable class is that it's structurally immutable, that it actually won't change out from under you, right? And then there's a third aspect of immutability, which I described in this blog, which is verifiable immutability. And I describe 3 different frameworks in this blog. I talk about what's available in Java 9+, because immutable collections were actually started being added. If you look at the convenience factory methods of list of, set of, map of, these actually return immutable data structures, but they are structurally immutable. They're not contractually immutable. List.of returns a list, and list is a mutable interface, right? Which means you can call out on it and it will throw on you. Similarly, in Google Guava, they don't have interfaces, but they do have implementations, and the implementations are restricted. They have abstract types, like an immutable list abstract type, and the way they're set up is basically you can only basically extend that in the package itself where it's created, right? So they've limited the universe of all the implementations by having abstract classes with private constructors. Everything has to be in the same package. Now, with Eclipse Collections, we have immutable types as well, and that's what I'm going to be comparing in the code here. With Eclipse Collections, we have this immutable list type. What's interesting with our immutable list type is it's contractually immutable, right? But it's also just a public interface, right? Which means anybody could implement this, and if you wanted to, you could implement immutable list and make your data structure immutable, right? There's no way for us to prevent you doing that, right? Anybody can implement this, and basically what you can do is like say, hey, I have something immutable, and actually be lying, right? It's not actually immutable, right? And what we wanted to do is try and solve for that problem where we want to provide the interface, have it be contractually immutable, and make sure that all of our implementations are guaranteed to be structurally immutable by being able to say, like, this is the full universe of them. So we basically restrict the only implementations in the case of the Custom Collections framework have to be named via sealed. So what you'll see is like we use the sealed keyword for defining our immutable collection interface, and then similarly for our immutable list, and we specify specifically these are the 2 implementations that are allowed, right? And I actually have an example here of the the code. I think I call it mutable immutable list. So if I want to implement a mutable list, first thing is I can define simply extend the array list type from the JDK, right? And so what you'll see is this is the JDK type of array list, and what I can do in immutable list is implement the immutable list API. And if you look in the blog link I sent you, down at the bottom, there's a full diagram of everything that's in the Custom Collections framework. And we have mutable classes interfaces defined, which they're not restricted. And then we have the immutable interfaces defined, and they're sealed. So all the ones in purple are sealed interfaces. And then there's a set of readable interfaces that are the parent interfaces between mutable and immutable. So we have a list interface, which, and this is not the JDK list, this is our own list interface type, that is the parent for both mutable list and immutable list. But if I I can actually define this class, and it works fine, to say I have a immutable list array list, but it's actually not immutable now. If I want to make it immutable, I can change the type here. I'm just going to complain about a few things, and I've actually commented out the code now to at least get rid of those complaints. It's going to say, you haven't implemented these methods, you have to implement them because they're abstract. I'm like, fine, okay. Let me go implement them. So if I unhighlight all of this, I'm going to get to having a final problem that the compiler tells me, which is mutable immutable list is not allowed in the sealed hierarchy. So basically, even if I wanted to implement this interface, I can't, right? I'm restricted from doing that. So the sealed interface, sealed interface approach that we're using, so kind of restricts the only things that can implement this interface of these two things. So the universe has basically been defined as this, and it's easy enough for us as developers to verify that this is immutable and that this is immutable by looking at the implementations, right? I mean, it's possible for us as framework developers to screw up and accidentally make an immutable thing mutable, but then someone can basically say, hey, you've got a bug, go fix it, and we go fix it, right? If you don't know the universe of implementations and people just implement them on their own and pass around things that are expected to be immutable, you have no control over it. So that's that. So what I'll do, though, is if you look at the Kata itself, right, we have the set of tests, and these are all the tests that we run for the deck of cards. Oops, I got to undo my code there. But I guess it shows us that the compiler is actually working. There we go. That should compile. So if I run the Eclipse Collections tests, I have all the tests passing today. Just it was to save time since we're limited on it towards the end, but I wanted to at least have the implementations available so we could compare them between the custom deck of cards using sealed types and our Eclipse Collections implementation. So looking at the Eclipse Collections implementation, what you'll see is we have the type immutable list of cards. We also have immutable list multi-map, which is basically grouping cards by suit. In order to create the cards, what we do is we get the lazy cards from the card class, and this basically returns that lazy iterable I described before. And what it is we just do a simple Cartesian product. And this is an API that's available in Eclipse Collections. You can do sets.Cartesian product with any two sets. We pass the enum set of rank and enum set of suit to them and construct a card out of the combination of these two things. And this gives us the deck of 52 cards, right, based on that Cartesian product of the two. So that's how you actually build the deck. The stream cards code does the same thing, but we have to implement Cartesian product. If you want to see what Cartesian product looks like implemented, we do it imperatively here. There's actually, if you do this, the deck of cards kata for like streams, and if we had time, if somebody wants to stick around, I can solve this later. You can get rid of the imperative code where effectively Cartesian product is just a nested for loop, right? Iterating over both sets, constructing then the card objects, applying this function, which you'll see the function is just this card new, right? And you can basically turn this into a flat map and map using streams. But so that's what lazy card is. Once we get the full list of 52 cards, or lazy iterable 52 cards, we can convert it to a sorted list and then just call to immutable. Now what you'll see is because this type immutable list here, if I didn't do this, the compiler is going to complain because to sorted list is immutable list. So I know, hey, code doesn't compile, I actually have to do something here. I can just use the APIs. Once I've got the immutable list, if I want to calculate the grouping of the cards by their suit, all I have to do, and this is the simple version of group by, where every card has just one key, which is its suit. But what you'll see is that card here, you see it's suit and it's not get suit, and that's because we changed card when Java 14 came out. We made it a record. So card is a record of rank and suit. But it does have all these behaviors, right? So we have the static methods, lazy cards and stream cards. These are all in the card class. We also have to implement comparable. So there's our compare to method. And what we do is we compare suit and rank, right? And they're ordered in the enum. So, and then we have just these simple Boolean methods to see if something's diamonds, hearts, spades, or clubs. So we go back. So this is what we do on Eclipse Collections to create the immutable list and then do the group by. And to be fair, like with the custom collections framework, we've only probably got like 4 or 5 days maybe of effort sunk into implementing it. And we were really experimenting with the APIs and putting the APIs directly on the collection interfaces, but using the same methods that you'd be used to in streams. And there's a separate blog that I have. You can actually see all the methods here, the names, like you see filter, filter not, map, flat map, which is different than the Eclipse Collections APIs. This would be select, that would be reject, this would be collect, that would be flat collect, peek would be tap. Group by is the same, although in streams it's called grouping by, right? but this is an active method. It actually creates the multi-map. So going back, so what we can see down here is we still now have an immutable list of cards, but this immutable list is the immutable list defined in the custom framework. It's the sealed interface, right? The way we can do it, though, is immutable list actually has a static method on it called fromStream. So we can create any immutable list from a stream by just passing a stream in. In this case, we're going to do card.streamCards, which is going to do that, manually imperative Cartesian product and then actually call sorted on the stream that comes back. And that gives us back the immutable list. And, this is fairly simple. If I look at it, it just creates a mutable list from the stream and calls toImmutable on it. Which is not too dissimilar from what we did here. We created an immutable list there and we called toImmutable on it, right? Once we've got the immutable list, then we have a special method. We have to sink more time into this if we want to, and it's a trade-off of cost and value, right? It's expensive to do, reinvent everything that we already have in Eclipse Collections. It's a huge framework, right? So having immutable multi-maps, that's weeks worth of work. I don't feel like doing it. So what we did was we came up with a minor hack where basically we have a special method to be able to group a collection as unmodifiable and make sure that the data structure comes back as unmodifiable. It's not an immutable data structure, like it doesn't have an immutable type. Otherwise, this would say immutable list multi-map, similar to what Eclipse Collections has. But it is actually an unmodifiable data structure. And this unmodifiable data structure actually should make everything unmodifiable. Yeah, it will actually wrap and return an unmodifiable array list multi-map. So once again, you've actually got kind of like a working collections framework here, and you can kind of see what the APIs then look like. When you get past the basics of, hey, we constructed an immutable list and an immutable list multi-map, and then corresponding, immutable list, but a mutable yet unmodifiable multi-map, you can see then the other APIs. And you'll see in Eclipse Collections, we actually have shuffle lists on our lists. So that's something typically you would call collections.shuffle in the JDK. You can actually do the shuffling directly on the list. In the case of this particular method, what you need to do is actually shuffle the deck of cards into a stack, which looks like a deck because we want to deal from the top, right? But you shuffle it 3 times is one of the things. And you can see for the custom framework, we've also added a shuffle method directly on the mutable list API, and you can do the same thing, right? We haven't implemented a stack yet, but you can use an array deck, and what you'll see is convert the mutable list that's been shuffled 3 times into an array deck and use the array deck push method instead of add. So you can use toCollection there to do that, and toCollection is just an API that we added on the mutable. Which one is this? Oh, it's actually enrich iterable. And it just takes a supplier and a buy consumer and just calls whatever method you've specified that you want to call there. So we go back. So that's that. Dealing, somewhat more complicated today because we haven't, once again, I haven't implemented all of Eclipse Collections in this new framework because that's a lot of work. It'd take me years. In Eclipse Collections, we have a mutable stack, and it has a pop method that takes a count. And this is useful for, once again, if you want to pop off, I guess, multiple things at the same time. So in this case, if I'm dealing, let's say 5 cards, I can pop off 5 all at once, right? Whereas I've got to implement that by hand in the custom framework today and, do some iterations. So I'm going from, let's say, range of 0 to count, and I'll be popping each card off of the deck that gets passed in. Shuffle and deal. Should be, yeah, it's pretty much the same. Deal hands. I'm using int stream here because once again, int interval is part of Eclipse Collections. It is an immutable int list. It has a from and a to and a step function, similar to int stream, but it itself is a list. It's not something lazy, although it can be operated on lazily. Let's see, deal hands. Yeah, they're somewhat similar, right? It's map to obj is the equivalent of collect, except here, when I do this, I'm getting back, a stream, right? And I've got to actually collect that to something. So what we did was on the immutable list type, we said, hey, you know what? Let's put collectors on each of the types. And what you'll see is the collector on immutable list takes a mutable list, starts off empty, calls add for each thing that you're adding to it. If it was done in parallel, it's going to merge them using with all, and the finalizer or finisher that gets applied is to immutable at the end. And this will give you back, you know, an immutable list. So it's easy enough to convert this stream directly into an immutable list just by doing this. Then the rest is fairly similar. We implemented count by. Count by returns a bag. We have all the same types. These are similar in structure, although we had immutable lists coming out of there, but we could have actually done that. Well, actually, no, that's not true. It's harder for us to do it here because we have that mutable list multi-map. Here, we actually have an immutable list multi-map, so we can actually specify that the type is an immutable type here. Whereas this is the readable type that we've defined with all the APIs on it. And so that's pretty much the same. So one of the last things, I guess, so in addition to, like, you can see how sealed types operate. If you check out the blog, it'll explain once again some of the theory and the problem that we were trying to solve, getting that kind of like trifecta of contractual immutability, structural immutability, and verifiable immutability. Like that was the specific problem we were trying to solve. But you can also see something interesting. One of the features that we're using, and it shows up on Mutable Collection, right? This is where we're using the feature. I'm trying to remember, I think it came out in Java 14, a preview feature. It's pattern matching for instance of, and that's actually being used right here. So we have this method add all iterable, which takes a Java lang iterable. And the interesting thing is, like, we have an optimization that says, well, if you're a collection, you can call this method, right? And this is the pattern matching of instance of. What it gets rid of is, like, you no longer have to do this and have this on a separate line, right, where you do a cast. This is what you would have done before. And let's see, maybe IntelliJ helps me. Hey, look at that. Replace a collection with pattern variable. Bam, gone. All right. That's pattern matching for instance of. And you can see, so you'll see that we have all the tests implemented on the custom side as well. They should all run. And they do. The solutions for this are actually checked in. The solutions for Eclipse Collections aren't, but as Sirisha said, we'll probably get around to eventually checking in solutions for all the deck of cards. It's more work because technically we have to do it for every single framework, right? You know, that's just you know, a bit of time that we have to spend on doing that. But you can, you know, go out and solve them on your own. So now I think one last thing I would add, and I know I've gone over a little bit. All of this stuff that we've been doing, showing like the katas and whatnot, this is like an approach, and I wrote an article for 97 things every Java programmer should know, and you can actually find that article up on the O'Reilly site. So if you don't want to spend the money on the book, you can at least get, you know, a free copy, a preview copy of one of the articles. Let me just find the chat. And in the article, which is titled Learn to Kata and Kata to Learn, I talk about basically using katas as a way of teaching yourself something. And all the katas that you've just seen, I used as a way to teach myself different Java features. And what we do is, the katas originally started out on Java 8. And what we do is we upgrade the katas immediately as soon as a new Java version comes out so that we can experiment with the new features. And what you can kind of see is, like, the katas, it hasn't been a real struggle to leverage the new features. It turns out, like, things like the donut kata and the deck of cards kata were well placed to use things like records, right? And the deck of cards kata, when we plugged in our own custom collections framework, when we suddenly got access, when Java 15 was released on September 15, I immediately set out and said, right, let me try and create an immutable side of this framework that, because what I had at that point, I had only implemented this portion of the framework, these interfaces. Then when sealed types came out, I was like, okay, well, let me do the immutable side, and then I'll add the readable side as well. So you get the full version of the framework, and you can kind of see like the evolution of this in one of my blogs. So the first blog I wrote about this, and my blog is just available at donrob.medium.com. If you're bored during coronavirus and want lots of things to read, I write a lot. But let's see. One of the, like I say, I blogged about var and a Varmia river. Okay, so I wrote this blog, easy, eager is easy, lazy is labyrinthine. And this explains the difference between eager APIs and lazy APIs and how eager APIs can make it easier. I'll just paste it here. Easier to learn and understand an API than lazy. Lazy is really a performance optimization. It's useful, and it's not like you want one or the other. You want both, right? But it's actually harder to understand how lazy works. But what you'll see is in this blog, actually, was it at the top? Yeah, there it is. So these were the original interfaces I added. They were only mutable, right? It wasn't until JDK 15 came out that I added the immutable. So, but those are all in the Katas. So you can see all the source code. You can see all the experimentation I've done. Once again, I wanted to learn sealed types, and I could read about, shapes and circles and squares and triangles, but I don't have those problems to solve. This actually is a real problem that as a collections framework developer I've had, and the way I solved it before was I couldn't solve it. We compile Eclipse Collections with JDK 8. I can't access features in JDK 15. In fact, it'll be quite some time before we upgrade Eclipse Collections to even JDK 11, right? Because we have, as Sirisha was saying, the lion's share of production apps are using Java 9 and Java 8, and typically like libraries have to lag behind applications themselves because they're still supporting older applications. And unless you say like, oh, we're not supporting that anymore, and then everybody has to upgrade, like we may have to make that decision at some stage. We did that with Java 7. Like Eclipse Collections up until Eclipse Collections 7.x supported Java 5 through 7 and worked with 8. And that was actually something Sirisha kind of showed. You'll see we just added this recently on the Eclipse Collection site. Hold on. We have this table now for compatibility. So you'll see like 7.x was compatible from 5 to 8. When JDK 8 came out, we started compiling, Eclipse Collections 8 came out, we started compiling with Java 8. At which point then 9 came out, and what's interesting is we had to basically, start to play nice with the Java, JPMS, right, the module system. They're pretty much like 9 and above, works with any version up until JDK 15 came out, and then JDK 15 actually broke Eclipse Collections, and there's a great blog from Stuart Marks about it. If you go to stuartmarks.wordpress.com, you'll see incompatibilities with JDK 15 char sequence is empty, and this is a long blog explaining basically an issue that we discovered it's actually been an issue that's existed since JDK 8, it's just nobody discovered it before. So if you're interested in that, you can read about that as well. But I'm going to stop talking. I went over. I'd say we covered a lot of stuff here. Hopefully you find the interesting features, and you can try the Katas on your own, right? They're out in GitHub. It's Apache 2.0 licensed. Definitely try them out, play with them. So, Sirisha, there's anything you wanted to
add? That's about it. Just come check out our GitHub repos, both for Eclipse Collections and the code Katas, and start our projects if you like them, and if there's something that you're learning from them. That's about it. Back to you, Mary.
Yeah, thank you. Thank you so much. Yes, a lot of materials. There's great materials. And does anyone have any questions for Don and Sirisha? Please feel free to turn on your video and audio and ask questions, or type in the chat to whichever way you're comfortable with. No? Quiet. I guess if it's okay, I like to ask too. So how does it work, right? Like, what are the differences? Because I see there Eclipse Collection streams, and then there's also stream, and there's also reactive streams. And the reactive operators, what are the differences, right? If we use it, so here you say lazy, so does that mean it's more a synchronous way of the implementation behind it too? Can you explain?
No, so with lazy, what it means is basically, let me think, where can I demonstrate this? What it means is basically that if you've got multiple operations actually being stacked together, let's say, in the case that Sirisha had, where she was filtering multiple times. She had select followed by select. Actually, Sirisha, you want to share your screen? We can show.
Sure. Did I turn off my video at some point? Okay.
And actually, I have a whole blog on this as well, by the way.
Yeah.
And actually, the eager and lazy actually explains it as well. The eager is easy, lazy is labyrinth. It explains it, but it's worth talking about. The primary difference is that in this case where you see as lazy, select actually doesn't do anything. When you call select, all it does is create a select iterable and hands it back to you. And it's done no operations at that point. So the predicates haven't actually been executed. When you call select again, that doesn't do anything other than return you now another select iterable. It's like a promise to, I'll do something later when you call a terminal operation.
Yeah.
So no execution has actually happened, right? Flat collect, similarly, it's not going to do anything. It's going to hand you a flat collect iterable. And what you're doing is you're stacking these iterables on top of each other. It's not until you call summarize double that the then pipeline of operations has to happen, right? But should be different if you got rid of the as lazy call there. And actually, why don't you want to debug it?
Sure, yeah. I'm
It's a
only
good way to look at it.
Run this one. Oh wait, I didn't have.
You don't have a breakpoint.
No, I didn't have a breakpoint. Oh, that's good. Can you see my this bottom panel here, Don? Okay, it's good enough, I guess. Okay, cool. I thought it was tiny. So yeah, there you go.
Okay, so I guess if you step over select, right? What are we able to see in the debugger? So at that point that you've executed select, the next call to select is operating directly on a list that was created off of select, right?
Yep.
I think, how do you actually show it? How do I actually see that? Yeah, it's not actually, you're not actually able to see it. Well, actually, look at the stack frame.
Yeah, I thought we.
You know what? Maybe if we stick the breakpoint inside of the lambda, right?
Somewhere here.
Yeah, because that will kind of do it. It's still hard to see, right? So yeah, I guess restart. Because that's the real difference with lazy. When you stick the breakpoint inside of select here, it's going to stop there as soon as select is called. When we do it lazily, it's not going to stop there. It won't stop until we hit summarize double. Okay, so you executed?
Mm-hmm.
Yeah, so look at where we are with the select method.
So right here.
So see select 383? Yeah, step there. So you can see where the code is right now. You see you're inside of a for loop? So we're already executing. The for loop's already happening. We're executing the predicate one by one at this stage, right? For every element in there. And it's going to return some, scroll up a little bit. Yeah, see look at the result R. You see target? It should be some, does it show its target? Scroll to the
R
right.
is Eclipse Collection.
Oh, you can see right there. Target is a fast list over in the variables. You see in the variable list, see target is a fast list. And so if you step through this code, like just step through it now, like one by one, you'll see like, you'll see like
there's a second select.
Target is, you see, yeah, well, you see target's now size is now 1. Went from 0. So it's already executing. Select is executing as soon as you call it, right? And it's creating an actual list. So the first difference is, like with eager, is that I'm going to create a collection right away. It's going to be a simple for loop. It's very easy to understand and reason about this. the execution, even like breakpointing on the lambda, the lambda is breaking on that if predicate except, right? That's where the breakpoint is stopping. But if we try and do the same thing lazily, and so what that means is, you can stop this and I'll go back and explain it. So the call to select is going to create a list. Oops.
Oh, did you want me to? Yeah, I stopped sharing. Sorry.
Actually, you know what? I can share. You have the solution checked in, right? Mm-hmm. Yeah, let me share. Forgot about that. Can you see my screen?
Yep.
It was in here, right?
That's right. If you go to the
there it is. Okay.
Yep.
And let me just. Which method is that? That's actually I can just break in there, I guess.
Yeah, that's what I did, but I used the lambda.
Yeah, so how do you?
If you just
right?
Yeah, right there, exactly. And
Yeah, so if if I do this and I make it lazy, right? What you'll see is that breakpoint's actually not gonna do anything, or it shouldn't. Did I run debugger? Oh, I'm running. Sorry, gotta go run the donut shop test. Which method is that? That's
donut price statistic.
Okay, so I can debug on this one then. Can you figure out where I am? You see, I put the breakpoint there. You see where I stopped?
Summarize.
It stopped on summarize. It didn't stop here, right? Even though I put the breakpoint there. But it's actually sitting on that. It's actually evaluating that lambda now. But if you look at the stack trace, right? This is why I say, like, the title of my blog is Eager is Easy, Lazy is Labyrinthine. Can you understand what you're looking at here? It's pretty complicated, right? Because what we've done is we've done 2 filters and a flat collect, right? Yeah. And there's quite a lot going in there. Actually, surprising amount. Yeah, so what's interesting is, I can't even, that's weird, I can't even see the accept code. Yeah, I don't know. It's hard to comprehend, but what I can tell you is that the benefit of this, and if you've ever tried to debug streams, it can be a similar struggle, right? To understand exactly what's going on. So debugging anything with lambdas and collections is challenging, especially when it's lazy, right? It's easier when it's eager, because you get a better expectation. And what's interesting here, though, is by using lazy, what it means is I haven't created a list here, I haven't created a list here, and I haven't created a list here. So I get rid of basically 3 temporary collections I would have to otherwise create that I'm just going to throw away, because at the end, all I care about is this, right? That's why I say it's an optimization, because it means that I don't have to create temporary data structures to finally come up with the final result, right? All of these things can be executed lazily. So yeah, that's the primary difference with lazy. But to your question, it's not happening in parallel. This is all serial. The eager serial, the lazy serial. It's really about the approach. And in the blog I sent, let me find that one. I explain how, and this is actually using code which you can find. All this code is in the code Katas. If you look at the filter test that we have for the Katas, and that one actually might be easier to just demonstrate now that I think about it. That's under deck of cards Kata. I'm going to look at the test for custom collections. And if I look at mutable list test, right? You'll see here this filter method. This is the filter method you saw in the blog. And what you'll see is this is the eager filter method. And if we stick the breakpoint here, right, you'll see that when we debug this, I'm not running a debugger already, am I? Did I stop it? Okay, let me stop it. Otherwise I'm going to get all confused. When I debug this, oops, sorry. You'll see like it stopped in the lambda, and you can see that I'm in the filter method, right? And that kind of matches what I see from the code, right? It's like I expect that I'm looking at the filter method when I stop here, right? So that's easy to comprehend and understand. It's still tricky to, you know, step through the debugger sometimes for these things, right? It's like, you know, you need to be using the debugger quite a bit to get good at it. But you can kind of like, you know, obviously when I'm looking at these things, the lambda is just going to say, hey, there's the code. But there I am in the actual for loop, and you can see what the looks like. I should be able to step over this. And you'll see it's stopping at this predicate every time, right? With a different result. And now it's finished. And no, it's not, it's still looping, right? But now I've gotten both elements out. Nope, it's still going. Yeah, it's going to go all the way till 5. So there's 5 elements I'm filtering over, right? You'll see it's stepping for each one. But you can see how it's stepping through the for loop, right? When it gets finally to number 5, this should be the last one. Now I should return. Yep. And now my result has 2 and 4, because what we were doing is filtering evens, right? Now I can see the result. And so now I should step out. And now I'm back to the mainline code that I'm debugging through, right? Now let's try and do that lazily. I'm going to put the breakpoint same place, right? I want it in filter. And now when I run debug on this, you see similarly, I'm not in filter, right? I'm in the filter test, but I'm actually in the collect method. Right? And if I try and figure out, I've got to go through this stack trace to figure out where's the actual loop that I can look at. And like now I look like something that might be an element in the collection, right? You have to know you'd have to look for each remaining, right? But it's not that simple for loop, right? Now it's this complex thing. And stepping through this is going to be kind of hard, right? I'm going to have to keep looking here. And you have to know, once again, where to look in the stack, right? Because this method actually was done as soon as it executed. Because if you look at what the filter method does, let me stop this. When you step in the filter method, right, for streams, what does it do? It does this. It gives me a stream, which hasn't done anything at this stage, right? Once again, it's lazy, so it hasn't executed anything. It's just a promise to filter later. It's not until you call collect with this collector that it's actually done anything, right? And the blog kind of walks through the explanation of this. And one of the interesting things, when you look at lazy versus eager code, the result's going to be the same. And actually show what the debugger looks like. So everything I just walked you through is in this blog, showing the debugger, showing the stack, showing where you are in the for loop so you can understand it. It debugs lazily, right? Show all that. But then the interesting thing is lazy, I show more examples. Like if you want to do filter map and then reduce, which is, you always hear that, those three things, right? Filter map reduce, that's the kind of things we want to do with streams. So I show like, here's a filter map reduce, and reduce is a terminal operation, right? Here in this case, we're going to take a list of numbers, filter out the evens, convert them to strings, and then concatenate them, right? And I would expect that my string is 2-4, right? Once I concatenate them. And I do it eagerly, and you see the only difference here between this and this is this is called a dot stream. once again, all this code is in the Custom Collections framework. You can execute it on your own. But the interesting thing is, when you look at the output, this is interesting, because what I'm doing is, you see how I'm calling these peek methods? Peek actually will, allow me to throw in effectively something to execute and then continue execute. So I'm just going to show where you currently are in the set of operations. So in the case of outputting for eager, what you'll see is we do filter 5 times first, then we do map twice, then we do reduce twice. That's eager. When I do it lazily, I do filter, filter, map, reduce, filter, filter, map, reduce, filter. Now, if you look, it looks like the same number of operations, right? Just in a different order. But the real difference is the lazy implementation didn't require that. In the eager case, filter created a list, map created a list, and then reduce, so it's ultimately going to throw the lists away, and come back with the string. So it becomes more interesting with lazy when the operation that you're doing has to actually do less work. So if you look at these set of operations where I do filter, map, and any match, right, where any match is a short-circuiting operation, it's going to be able to stop as soon as it finds the first one that equals 2, right, and say I'm done. Now in the output for eager, it's going to say, well, you did filter 5 times, because I still have to filter everything. I do map twice, and then I finally have to, it's going to wind up executing any match twice as well. In the case for lazy, it's actually doing less work, right? I filter twice, I hit map 2, 2 matches, I'm done, right? And no temporary collections created, and it can jump out immediately. And it's interesting, I found it useful for myself once, writing the katas this way and writing these tests so I could explain it to myself. How does this stuff work? And then blogging about it, showing like, the ordering is interesting, right? But all of this, once again, it's all serial. Yeah, if you throw this, you can throw the complication of it making parallel, and I have a separate blog for that. But that's using, in the case of streams, right, I can just do this. Okay. And now who knows what order things are going to happen in, right? And what it'll do, because that's going to then be, once again, executing against multiple cores. In Eclipse Collections, we do have parallel APIs. We have our own thing. It's called as parallel, and it returns a parallel list iterable, and it forces you to pass in an executor service and a batch slice. Because what we kind of find is like, we wrote our parallel code probably like 15 years ago, and what we found was, because we were writing this in large, financial services apps, very large caches, doing heavy parallelism, we found is like, most of the time when you're doing parallelism, you tend to know what you're doing and you want to control these things. And that's what you see a lot of the times, people, complaining about streams that like, hey, how do I control the, the fork join library and specify the number of threads I'm going to have, right? And can I use this for I/O and all this stuff? And we said, well, this is such a common ask, we should actually just force it in the API. Because it also then makes it so that switching from stream to parallel stream is just typing different text, right? I can just do that and magic is going to happen, right? What we do is, like, in our APIs, we say magic's not going to happen. You have to know what you're doing. You should really have proved that parallel is going to give you a performance benefit, and then you probably will want to tune that anyways. So it's not as easy switching to our parallel API. You have to know what you're doing and you have to measure it. And that's my recommendation. You shouldn't be switching to parallel anyways, unless you know that you have a performance problem and you can prove that you're actually going to get a benefit. Because all you might be doing is keeping your CPUs warm in the server room and actually making things slower. You really have to have benchmarked it to tell. So I don't know if that was a long answer to your question.
Oh, that's great. Yeah, very difficult to thank you. Yes.
Yeah.
Anyone have any questions for Don and Sirisha? I guess Rodrigo asking something.
There was also a question before that from Nilesh on the same topic. If there's a scenario where eager is preferred over lazy.
Yeah. Lots of scenarios. Okay. Actually, in the blog, it explains it. Eager or lazy. And And actually, you know what? I got to go to another blog for it. It's this one. Hey, look, I got the link to the blog right there. So this is a blog I wrote a couple years ago, and it's about performance optimization and lessons I learned driving from Florida to Williamsburg, Virginia. But I talk about different strategies for optimization. And in this blog, I do a lot of the same explanations of eager versus lazy, how they operate, the ordering differences, the result difference. But the thing, to answer your question, I finally give at the end is recommendations, right? When would I use? First thing, I always prefer primitives over boxing, right? Don't box. I hate auto boxing. Why did we ever have it? The nice thing is, though, you got to have primitive collections to get rid of boxing with collections. So I prefer eager for single or fused operations. If you know you're only going to filter, the fastest thing to do is to filter eagerly, right? Or to, let's say, do a transformation. You've got a single call to, let's say, map or filter. The fastest thing to do is to do it eagerly. Don't do it lazily, right? But if you've got multiple operations stacked together where you may be creating temporary data structures, you should prefer lazy for that, right? With the understanding that you're doing a performance optimization. It's going to be easier both to read the code and to debug the code if it's eager. But what you can easily do is you can easily switch from eager to lazy when you know that doing it is going to give you an optimization, let's say, of not creating temporary data structures. And then my last recommendation is like, you want to use parallel, you better prove that you have a performance problem, because otherwise you're just going to hurt yourself. So I think that's been a fairly common recommendation by a lot of other folks out in the industry. So that answers the question. I see. Can I tell more about the bug we found with JD Java 15? Sure. Let me switch to Eclipse Collections. Okay, so the bug that we found, and what's interesting about it is I wrote this code 5 years ago. It worked fine until JDK 15 came out. And Stuart actually explains this in detail in his blog. So if you look since version 7.0 of Eclipse Collections, so the first release of Eclipse Collections, which Eclipse Collections was migrated to the Eclipse Foundation in 2015. It started off as a framework called GS Collections, but I had implemented char adapter. And char adapter is basically a wrapper around a string, which gives you rich behaviors for dealing with strings, because technically strings are collections. They just don't have a collections API in them. They have a very specialized API, right? But what you can do with the char adapter is it does what it says. It adapts a string, and it basically provides it implements two interfaces, or three interfaces here in addition, well, two in addition to being serializable. So it implements both char sequence, and char sequence is the JDK interface, right? And if you look in char sequence, and I'm looking in Java 8 right now, you'll see that there is no isEmpty method, right? Everything's good. Now, if you look in the other interface that a char adapter extends is immutable char list. And when you go into immutable char list, what you'll see is there's an isEmpty method, and it's a default method, which means I don't have to implement it myself. In char adapter, I get this implementation for free, right? Unfortunately, what happened in JDK 15, and I can switch over to the code Katas for that. So this is using JDK 15. When I look at, actually, I can see char adapter here as well. So char adapter, you can see implements char sequence. Now this is char sequence to JDK 15. Magically, you'll see there's an isEmpty method. And lo and behold, isEmpty is a default method. And the reason this creates a problem is that, well, char adapter extends char sequence and it has an isEmpty method that's a default method, and also extends immutable char list, and it has a default method called isEmpty. Which one do you use? And that's where you run into a little problem, right? And what you get, and Stuart explains this in his blog, he actually includes our the specific implementation, you'll see char adapter, and he's got implementing primitive, iterable, and char sequence is technically implementing immutable char list, but the result is the same. It's effectively like you try and call that. What you get is this incompatible class change error, conflicting default methods. Primitive iterable is empty and char sequence is empty. Now, you think, well, that's not such a big deal. Except that what this has kind of uncovered is that if you add default methods to interfaces, you have to be kind of careful that someone else out in the universe doesn't already have a default method in another interface where you might have a diamond hierarchy where both interfaces are implemented. Because if you do, you're going to break them, especially if you're an interface in the JDK, which potentially has millions of opportunities for folks to, mix and match things, right? And that's what effectively happened here. Now, the solution to this problem, we had to get a fix out quick for it, was in char adapter now, we had to define as empty, right? And it's really providing the same implementation, but it's like, you see, there's the two default methods. We can't use them. We have to override it and say, this is the implementation, right? So that was the fix. But what it means, once again, is the JDK developers have to be very careful when they're adding default methods to existing interfaces, that there's not some other developer out there that has done something like implementing an same method name on a different interface. And it's funny because this problem was seen in a different way once before. And it was when default methods were first introduced in Java 8. A method was added, several methods were added to the list interface. But the one that actually caused problems, and it specifically broke GS Collections right before we open sourced it. So luckily, before we open sourced GS Collections, we had already gotten the fix in. They added a sort method on the list interface. Now, that's fine, except there might be folks in the universe that have already extended list and added their own sort method. And if their sort method matches in terms of the parameter that it takes, what happens if the return type doesn't match? Problems are going to ensue. And as it turns out, in Eclipse Collections, our mutable list interface, oops. Yeah, that one. Had a sort method. Now this is the sort method from list. That's not the one we want. We had to rename our sort method. We named it sort this. But you see sort this? The signature is the same. It takes the same parameter, takes comparator, but the return type was different. It wasn't void, right? So this causes an even worse error if you've got basically a clash. So anytime default methods are adding to existing interface, you've got these different vectors now that you have to be aware of where you might wind up into issues with code that already exists out in the wild. And once again, these are two different examples, but they both revolve around the challenge of, extending existing interfaces using default methods. So that's why, once again, it was it was a surprise to us. It was a surprise to Stuart Marks as well. And, he wrote this amazing long blog explaining it and what the issue is. So I would definitely recommend checking it out. It's a really interesting study of, how things can happen. And also the benefit of one of the things that we do in Eclipse Collections, we participate in the OpenJDK Quality Outreach Program. And this is a great program that open source libraries can participate in and basically register that they have tested the libraries that we're working on against different versions of the JDK. And what you'll see is, like, for Eclipse Collections, we've certified against all versions of the JDK up until even the early access version, current version of OpenJDK 16, right? And we report, and it's important to be in this kind of program because what we can do is, and we did this right away, JDK 15 broke Eclipse Collections before 15 was released. We found out the issue when it was early access, pretty much like 2 or 3 weeks before. We reported it immediately, And what they did as a result, you'll see like they put in this comment that we're compatible. This version is compatible with 15 or above, but also they added information in the release notes about this method, right? I'm not sure which link goes to it. Yeah, you'll see this bug at OpenJDK, right? And what they've done is, there we go. Go back, there's the other link.
We were able to document this change in a release note. It says that if you...
Did they say that?
Yeah.
If you can read my own text on the screen. Okay.
It's in the last line in the first paragraph.
Here?
Oh, no. If you go back to the blog, Stuart Mark's blog.
Okay.
It's the last line.
Okay, there it is. There it is. Thank you. That's what I'm looking for. Yeah, so they specifically added this text to the release notes to explain this because it's important. You know, it's good. Maybe Eclipse Collections is the only framework that bothered adding something that has its own interfaces that extend and, you know, have a diamond hierarchy with char sequence. Let's hope we're the only ones. But, you know, our kind of philosophy on this as well is it actually makes sense to have these empty method because guess what? We already had exactly the same as empty method already defined, right? Because it's a useful method to have because saying this dot length equals 0, I can't use that with a method reference if I'm like filtering and stuff. You know, anywhere I'm using predicate, so it's painful to use, right? So this is useful to have. So again, it's a long-winded answer to the question. Hopefully it answered it, Rodrigo.
Thank you. Thank Don and Sirisha again for really great, very in-depth presentation. It's been wonderful. And if anyone still have any questions, you can reach Don and Sirisha. I guess what would be the best way, like Twitter?
So you can always, follow on Twitter or like if you have my Twitter handle. I think, obviously, like if you, find anything interesting as well in Eclipse Collections that you want to contribute or whatnot, like, we're in the GitHub issue tracker all the time, and also, reviewing pull requests and submitting our own when we can for new features. And, I wanted to actually give a shout out because I know, like, in a little bit of, friendly pressure for Sirisha's contributed a bunch of new set operations to our primitive sets, and she's got a blog in the works for that. I don't know if Sirisha, you want to share your Twitter handle and.
Yes, so my Twitter handle should be part of the meetup bio, but I can also leave it out here. Also, if we're also looking to build our Pittsburgh Jug community, I know people are active on Meetup, but not really on Twitter. So I'm unable to tell where we're able to attract the audience and to, I'm trying to share as many Jug events possible, so hopefully people are seeing it. We're not always posting them on Meetup, so if you could even follow the Pittsburgh Jug handle, that'll be awesome. I'll leave the links for it right now in the chat. That's it.
Great. Thank you, Sirisha. Thank you again, Don. So with that, I think our meetup tonight has come to an end, and I'm not closing this yet. If you want to hang around and talk some more, I'll leave this online for a while. You can go and get some drinks and make this a virtual drink. So it's kind of a thing, grab some food from your fridge or whatever. And we can still hang out too. So, but thank you so much again for joining. And thank you for Don and Sirisha again for a great presentation. And and thank you for everyone for having stayed this whole time. I think a really lot of respect for you for being so patient and sitting through the whole night. It's kind of 2 hours long, so thank you so much. And okay,
no problem. Thank you for having us present today, and Well, I've done this once before with you, and you know me, I'll hang out, and I'm happy to code all night. So,
Wonderful.
folks want to ask questions and drink, that's fine.
Yeah, okay. Thank you. Yeah, and happy Thanksgiving to all. If you're in the U.S., we celebrate Thanksgiving. So, yeah. And okay, so with that, I actually will stop the recording, and then we can continue to talk to. So.